This video is for section 8.3, bonding theories. In particular, we're going to look at the VSEPR theory. The learning goal is to understand how VSEPR theory predicts three-dimensional shapes of molecules. The VSEPR theory, or VSEPR theory, stands for valence shell electron pair repulsion. That phrase refers to the fact that in a molecule, shared and unshared electron pairs repel each other so that they're as far apart in space as possible. Here are some examples of molecular shapes, and on page 243 of the textbook there are more. One molecular shape is called linear. A linear molecule has a central atom with two bonds to other atoms and no unshared electron pairs. Here's an example of what a linear molecule looks like, where the circles represent actual atoms, and the connectors are the covalent bonds. Another shape is called trigonal planar. This shape occurs when a molecule has a central atom that is bonded to three other atoms, and there are no unshared electron pairs. Here's an image of that. Notice the triangle shape, hence the word trigonal, and that it is flat, the word planar. Another shape is called bent. This occurs when the central atom is bonded to two other atoms, and there are also one or two pairs of unshared electrons. And here's a drawing of that. The unshared electrons are on the central atom. For instance, maybe this red circle is an atom that has two unshared pairs. Let me put in some dots. Here and here. Because those electrons are negatively charged, they will repel or push against the electrons that are in these covalent bonds. That's what forces the molecule into a bent shape instead of staying in a straight line. Another common molecule shape is tetrahedral. This has a central atom that is bonded to four other atoms, and there will be no unshared electron pairs. This image shows an example of a tetrahedral shaped molecule. The big green thing is the central atom. It's connected to one atom straight above. Then this one comes out of the paper towards us, whereas this one here and this one here go backwards into the paper and are angled a little bit downwards. Here's a model of a carbon dioxide molecule. Carbon's the gray circle in the middle, and the orange circles are oxygen atoms. Carbon's connected to each oxygen with double bonds. You'll notice that because all of the electrons are in those double bonds, that there are no unshared pairs on the carbon. This creates a linear molecule. The bond angle is 180 degrees. Here is a water molecule, H2O. You'll notice that this is bent, and that bent shape is being caused by the unshared electron pairs on that central oxygen atom. Those negative electrons are repelling the electrons represented by these connector lines, and that forces it into a bent shape. The bond angle here is 104.5 degrees. This molecule is SO2, sulfur dioxide. The yellow circle in the center is sulfur, the orange ones are oxygens. There are some double bonds, but because the sulfur has an unshared electron pair pushing those double bonds downwards, this does not end up as a linear molecule, but as a bent molecule. The bond angle is 119 degrees. This one here is NH3, also called ammonia. This shape is pyramidal. It's not trigonal planar because it's not flat in three-dimensional space. That unshared electron pair is pushing the bonds downwards, creating a pyramid shape. The bond angles are 107.8 degrees. This one here is CH4, or methane. This is a tetrahedral molecule. The four hydrogen atoms are physically as far apart as is possible in three-dimensional space. And that occurs when the bond angles are 109.5 degrees. Here are some check for understanding questions. Please answer them. I'll pause the video for you to do that, and then we'll discuss your answers. The answer to number one is tetrahedral, because the molecule will have carbon in the center, and that will be bonded to four chlorines. for the chlorine atoms to be as far apart in space as possible, they would have to have a tetrahedral arrangement. Number 2 is going to be pyramidal. And here's a drawing of the ammonia molecule so you can see why. Nitrogen is the central atom, and then it's connected to 3 hydrogens, but there's an unshared electron pair on top of that nitrogen. Those negative electrons push against the electrons in these bonds, pushing them downwards into the pyramid shape instead of staying as a flat trigonal planar shape. Number 3, water is bent, and this drawing shows why. Because water has 2 unshared electron pairs on the oxygen. Those negatively charged electrons repel the electrons that are in these bonds, forcing them downwards so that it's not a straight line. Number 4 could have many different answers. My answer is CF4. I envision this as having carbon in the center with 4 bonds coming out of the carbon to the fluorine atoms. This concludes the video about the VSEPR theory, valence shell electron pair repulsion. That theory explains the 3-dimensional shape of molecules, that the atoms in the molecules orient themselves so that they are physically as far apart as possible from the other atoms in the molecule. This is all caused because negative electrons will repel other negative electrons.